Our last lightning talk for this afternoon session will be by Diego Lirman and focusing in on the role of reef restoration, coastal resilience, with a different title as compared to the program. And I'll single you at 2 minutes.
All right, thank you. All right, so thanks for sticking around. So if you see the list of talks, the expertise in this room, and over the next couple of days, you see the focus of this workshop, of this meeting, is on the climate drivers, the impacts of climatic extremes on coastal ecosystems, and of course on humans. So I'm here to speak on behalf of the natural ecosystem, because it seems to be missing from this workshop. And for two reasons. First, because natural ecosystems, and here locally we're talking about coral reefs, mangroves, and seagrasses, are extremely susceptible to climatic extremes. We know that. But more importantly, for the purpose of this meeting, because these are the natural defenses that we have to fight naturally climatic extremes. So the two are tied together: the state, the health of the natural ecosystems, and the resilience of our coastlines, and the human populations that depend on the status or state of the coastlines are intertwined. So to address this issue of natural defenses, we assembled a team under the umbrella of the ULINK program, which is a UN-funded program that produces big solutions for big problems. And to be able to address that, is there a clicker? We assembled together a team of engineers, modelers, reef ecologists like myself, as well as architects and communicators, as well as partners within the community, to address the issue of coastal resilience and the role that natural defenses play on coastal resilience. So this is our ULINK team, and we've been working together for the past 2 years, and it's been extremely rewarding because I'm learning from disciplines that I would never get to learn from just because we're not forced, but decided to or prompted to work together. So work that Landolf is doing, that Brian House is doing in Assist, Sustain, as well as our other collaborators, have really expanded my view of coastal resilience. So again, I'm here to speak on behalf of coral reefs, and again, but this graph can also apply to the state and the trends experienced by mangroves and seagrass ecosystems, anywhere you go. So regardless of the actual values, we've gone from about 40% to 50% of the bottom covered by stony corals to less than 5%. Here locally, in most cases, less than 2%. So we've lost a tremendous amount of biomass, of biological diversity, but more importantly, for the purpose of coastal resilience, we've lost a tremendous amount of structure. And it's the structure that protects our shorelines. The causes for the declines are multiple, are beyond this presentation, but nevertheless, what you need to know is that our coral reefs, our mangrove shorelines, and our seagrasses presently are just at a fraction of their structure and biomass compared to what they were about 40 years ago. So what we lose is we lose the ecosystem itself and all those ecosystem services that they provide, fisheries, tourism, recreational opportunities, but we also lose structure. When we lose structure, we lose protection. So recent research that's been published, conducted by the Nature Conservancy, USGS, and other partners has shown very clearly the value of healthy coastal ecosystems for coastal resilience and coastal protection. So you don't need to see the numbers, but you can tell very easily that when you lose about a meter of healthy reef, you lose all of the protective services that these ecosystems provide. So more people get displaced, a larger area gets flooded, more resources are lost because you don't have the healthy reefs protecting the shoreline. So this is a global study. Locally here in South Florida, over $675 million of protected value are lost on a yearly basis when you lose the coral reefs. So it's extremely important to mitigate the impacts, but also use the available strategies and techniques to recover what we've lost over the past 4 decades. the rationale of the motivation for us, especially here, because just behind you, a couple miles behind you, lies the most vulnerable and most valuable shoreline in the whole of U.S. So this is what we're trying to avoid. This is a recent article in the Herald that highlights the fact that the federal government is now spending over $150 million in Florida alone replenishing the sand that we lose because of these climatic extremes. So again, there's a pressing need to recover these natural defenses that protect us against all of these undesired outcomes. And also, we need to think about the people. It's not just the shoreline, it's also the vulnerable communities that lie beyond the shoreline. This is work that Sonia Chow from the School of Architecture has done, highlighting locally here in South Florida, in South Beach, the high vulnerability of our social and cultural resources just beyond the shoreline. So this is what we need to protect, and the best way to do it is by preserving the natural defenses first. So the work that we're doing as part of the ULINK program includes three components. The first is to design, and Landel made an excellent introduction to this problem, to design hybrid structures. Yeah, we can build things, but we now are also able to populate these structures with nursery-grown corals, or in the case of the sea hives, with seagrasses. So we can now build hybrid structures, gray-green infrastructure that combine the benefits of both approaches. The second component is to test these structures in the sustained facility. Again, just behind you, one of the most amazing model systems that you can use to test the impacts of climatic extremes on these hybrid structures, but more importantly, the benefits of these structures for coastal resilience. And finally, we are set to deploy our first test structure along the shoreline of Miami Beach so that we can go from the tank to the actual shoreline and see if these structures, these hybrid structures, do what they're supposed to or hypothesized to do. So this is the approach that we're taking. We're building all sorts of different gray, in this case, this is wood, but eventually it will be cement or concrete that will be deployed as a breakwater, and we're covering them with coral skeletons to mimic what our actual restoration will look like once we deploy these things. And then we test them in Sustain, the facility that Brian House runs, that allows us to actually test at scale these structures. So I'm going to show you very quickly. This shows one of our structures being deployed, and you can see this is an area that doesn't have the protection, and you can see the wave just going straight through, whereas over here you see the wave breaking. So that is what we want. We want these structures protecting our shorelines. And these are some results from our recent tests within Sustain. You don't really need to follow the numbers, but just to see that whenever you have structure, especially if it's covered by corals, you see a reduction in wave height and wave energy, and also that the amount that this energy is dissipated, or the energy dissipated, or the benefit that we get depends on the characteristics of the waves, and also will depend on the attributes of the coral community that we are developing. But nevertheless, very promising results. You know, we do get the benefits that we hypothesized in the past. And finally, this is our last step. This is the deployment that we're planning to do. We're using different structures. They will be deployed just offshore of Miami Beach, and we'll test the different shapes of the gray portion of these deployments, as well as the different types of corals that we're hoping to glue onto these structures. So stay tuned. Maybe next time around, we'll be able to show you some of the results from our field deployment. But the take-home message is we need to work on hybrid natural defenses that combine the benefits of gray infrastructure with the expanded resources that we're getting from our restoration programs to be able to protect our shorelines. Thank you.
Thank you, and we can take one question for our last lightning talk. Ben.
How do you test whether the efficacy of the deployed structures? How do you know that they're going to be effective?
Well, they've been effective at scale in the tanks. So the next stage is once we deploy these structures, at real scale, then we're going to deploy sensors to see whether those impacts get realized at larger scale. And so that's the next step. We are going to deploy these hybrid structures, and then we're going to instrument the hell out of these, and then we're going to measure, hopefully, all of the benefits that we have seen in the tank and from larger models. Thank you.
Great. Thank you so much.